look at the sign convention. A sign convention is very important when it comes to numericals. We will have to use these sign conventions to know how we can convert and how we can understand the data that is given to us. So well, for this, it's important that we know the Cartesian coordinate system. This is the x-axis, the center point. Everything to your right is positive. Everything to your left is negative. So this is your x-axis, correct enough? This is your optical center. Is taraf +1, +2, +3, -1, blah, blah, blah. Now, there is a y-axis, right? So the y-axis is above and below. So how is this Cartesian coordinate system formed when the x-axis is rotated this way, upside? Yeah, it's rotated upside. So this is positive, so this is positive. That is positive, this is negative. So here this is positive, here this is positive, and here this is negative. I hope I'm clear till now, right? So now whenever you look at things from the lens point of view, so let's say this is the ray diagram that we've drawn of the lens, right? So you will have to imagine that this is your x-axis and this is your y-axis, and the optical center is the origin always. So the optical center is your origin. I'm saying your optical center is nothing but the origin. Now you must also always remember something, that distance is measured on the x-axis, height is measured on the y-axis. Distance is measured on the x-axis and height is measured on the y-axis. So let's look at a particular image. Okay, so let's look at this only. So let's say I'm keeping the object here and the rays of light are coming and it's going and it's going and it's meeting somewhere. Okay, it's meeting somewhere. Now, for me to understand this distance, what is this distance? This is the distance between the optical center and the object. So for the distance, I will be looking at the x-axis. The x-axis, whatever value it has, it will be a negative value. On the right hand side, now this is the image, so this is the image distance. So the object distance is u. The image distance is v. So this is the initial and this is the final. So for u, the sign of u is always on the x-axis and that too on the left hand side. The v is mostly on the right hand side. There is only one case when the v will be on the left hand side. So for a convex lens, u will always remain negative. For a convex lens, v will mostly remain positive. There is only one case when v is negative. You know when is that? When the object, when the position of the object is between f and optical center. Only in this case the image is formed on the left hand side. Otherwise, every other case v is positive. Now let's look at one more thing. What is this? This is the height of the object. What is this? Height of the image. Now height है तो मुझे जानना है कि इसका वैल्यू क्या है. सो इसका वैल्यू क्या रहेगा? जो भी y एक्सिस का करस्पॉन्डिंग वैल्यू रहेगा वो ही इसका भी वैल्यू रहेगा. सो लेट अस से दिस इज 2 centimeters. So this is also 2. Now this is on the upside, therefore it is +2. So the object height, O is the object. Object height is always positive. No matter what, it is always positive. Now the image height, the height of the image is mostly negative. सिर्फ एक ही ऐसा केस है जब वो इमेज का हाइट जो है वो पॉजिटिव होता है. अगेन द सेम केस. Yeah, because in this case, when the object is placed between f and the optical center, the image is formed this side. When it is formed this side, we take the value corresponding to the upside of the y-axis. So this is mostly negative. This is a sign convention for a convex system. समझाना आपको. So let's take a typical example. So over here, let me say this is my principal axis. Okay, so this is my principal axis. You can see it, right? My principal axis. And this is my lens. I'm taking, say, 3 units up and 3 units down, and I'm making my lens here. So this is my lens. Now, so I'm saying 2 focus and 2, again, the 2f. So this is focus and this is 2f. Similarly, focus and 2f. Okay, so every image will be on this guideline in this grid. So let's take one example where I'm keeping the object here. I'm keeping the object here. Okay, so where should the image form? Now you know the image should form anywhere between this, because the moment I keep the object beyond 2f, the image has to form between f and 2f. So let's take the first ray of light and then it's going through the focus. Let's take the other ray of light which is going from here. So it's meeting over here. Is that okay? Is that okay? Tell me. Great. So now look at this. What is this? This is the object height O. What is this? This is the image height I. What is this? This is the distance of the object from the optical center. So this is U. What is this? This is the distance of the image from the optical center, which is V. So we have U, we have V, we have O, and we have I. Okay? Now U देखते हैं. This is U. U is positive or negative? It's on the negative side, on the left hand side of the x-axis. Therefore, it is negative. What is V? It's positive or negative. What is V? V is a distance. For distance, I will check the x-axis. It is on that side. Therefore, it is positive. What is O? O is height. Therefore, height I will refer to x-axis. Therefore, it is positive. What is I? I is height of the image. Height, therefore y-axis. ये नीचे है. Therefore, I'll refer over here. Therefore, it is negative. Cool? Are you getting a fair idea of what is U, what is V, what is O, what is I, and how you should be checking this? U and V are distance. Distance is always on the x-axis. O and I are height of image and object respectively, and always on the y-axis. So let's directly get into the numericals now, and for the numericals you will need three types of formulas. The very first one is called as a lens formula, which is 1 upon f. 1 upon f is the focal length. Remember the focal length? So if this is the lens, and this is 2f, f, optical center, f, and 2f. So this is f. What is f? F is the distance from the optical center. This is the focus. Every lens will have two focus, and this is twice the focus. Okay. Now in a convex lens, remember a convex lens, this is how the rays of light go. The rays of light goes like this. So the focus is always on the right hand side. So the focal length is this. This is the focal length. So the focal length is positive. The focus for a convex lens is always positive, and for sign convention purpose we will always consider the rays of light traveling from the left to the right. From the left to the right, all the rays will travel this way. So the lens maker's formula says 1 upon f is equal to 1 upon v minus 1 upon u. That's the first formula that you will be having. The second formula is the formula for magnification. Now magnification has a formula which says m is equal to V upon U, and V upon U is equal to I upon O. Therefore, M is equal to I upon O is equal to V upon U. That is what magnification is about. Now, what does magnification tell you? It tells you at whether the image is magnified or diminished, and if yes, what times it is. That's the second formula. The third formula is the power of the lens. Now, power of the lens is equal to focal length inverse, 1 upon focal length, and the focal length should be in meters. So if they tell you the focal length is 10 centimeters, what will you do? You will step 1 convert it into meters before you put it in the formula. You will convert every other unit of distance into meters and you will put it over here. Now the unit of power is diopters. It's called as diopters. Clear? Diopters. D-I-O-P-T-R-E. So three formula. Say with me. 1 upon f is equal to 1 upon v minus 1 upon u. Magnification m is equal to v upon u. Now v upon u is equal to I upon o. Therefore m is equal to v upon u is equal to I upon o. Power of a lens is focal length inverse, and the unit is diopters.